Good day! Welcome to our math tutorial. For quarter 4, week 5, we will be discussing on parallelism and perpendicularity. We will determine the conditions under which lines and segments are parallel or perpendicular. And we are going to solve the measures of angles formed by parallel and perpendicular lines. Now remember, when we talk about parallel lines, these are two coplanar lines which do not intersect, while perpendicular lines, these are two coplanar lines which intersect and form right angles. To prove that two lines are parallel, the following postulates and theorems can be used. We have postulate for corresponding angles, wherein if two lines are cut by transversal and their corresponding angles are congruent, then the lines are parallel. Then we have theorems for alternate interior angles and for alternate exterior angles. If the lines are cut by transversal and their alternate interior angles as well as their alternate exterior angles are congruent, then the lines are parallel. While consecutive interior angles, if the two lines are cut by transversal and the consecutive interior angles are supplementary, meaning when you add them is equal to 180, then the lines are parallel. To prove that two lines are perpendicular, we have also to remember these following theorems. 1. If two lines are perpendicular to each other, then they form four right angles. 2. If the angles in a linear pair are congruent, then the lines containing their sides are perpendicular. And 3. If two angles are adjacent and complementary, so meaning when you add them it's equal to 90 degrees, the non-common sides are perpendicular. So let's try some examples as applications of parallelism and perpendicularity. Directions. Is it possible to prove that lines M and N are parallel? If so, state the postulate or theorem you would use. Let's look at number 1. So if we're going to look at the red mark, these two pairs are alternate exterior angles. Now since they are congruent, then we can consider lines M and N parallel. Number 2. We have there one exterior angle and one interior angle, but both of them are on different sides of the transversal. We cannot consider lines M and N parallel because we don't have any postulate or theorem that will satisfy this condition. Number 3. So we have here one interior angle and one exterior angle. So we can consider these lines M and N parallel because these two pairs are corresponding angles and corresponding angles are also congruent. Number 4. We have here another alternate exterior angles. So lines M and N are considered parallel since the alternate exterior angles are congruent. And number 5, both angles are also congruent and they are considered alternate interior angles. So we can conclude that lines M and N are parallel. Let's try this. Is it possible to prove that lines J and S are perpendicular? If so, state the theorem you would use. So for number 1, we have their angle 4 is a right angle. So since it is a right angle, we therefore conclude that angle 1, angle 2, and angle 3 are also right angles. So we can say that lines J and S are perpendicular by theorem number 1 presented a while ago. Number 2, angle 1 and angle 2 form a linear pair and both of them are right angles. So therefore, lines J and S are perpendicular by theorem number 2 presented a while ago. Number 3. So we have there angle 1 and angle 2 are acute angles. They are adjacent and at the same time complementary. So lines J and S are also perpendicular based on theorem number 3 presented a while ago. Let's have this. Is ray BA perpendicular to ray BC? Now we have to add the two measures of acute angles. We have 63 degrees and 27 degrees. So if we add them, they sum up to 90 degrees. Therefore, these two angles are adjacent and at the same time complementary. So they form a right angle. So therefore, ray BA is perpendicular to ray BC. Number 2, is ray BA perpendicular to ray BC? So if we add 52 and 28, that gives us 80 degrees. So therefore, ray BA is not perpendicular to ray BC. Let's try this one. In the diagram, A is perpendicular to B. We have to find the value of x. Now let's look at number 1. So we notice there 62 degrees and x plus 14 degrees are given. These two angles are complementary. So our equation would be 63 plus the quantity of x plus 14 equals 90. Then we remove the grouping symbol. That's 63 plus x plus 14 equals 90. So applying the subtraction property of equality, so we have there x equals 90 minus the quantity of 63 plus 14. And then 63 plus 14, that gives us 77. So we have there x equals 90 minus 77. And 90 minus 77 is 13. So therefore, the value of x in number 1 is 13. Let's have number 2. We have there x plus 55 and the symbol of a right angle. So they are supplementary because they form a linear pair. So our equation would be x plus 55 equals 90. Then applying the subtraction property of equality, that gives us x equals 90 minus 55. And 90 minus 55 is 35. So therefore, the value of x in number 2 is 35. So for number 3, it has the same concept with number 1. 2x minus 9 and x are complementary. So our equation would be the quantity of 2x minus 9 plus x equals 90. Then I remove the grouping symbol. That gives me 2x minus 9 plus x equals 90. Then we apply the addition property of equality. So we have there 2x plus x equals 90 plus 9. And then we add 2x plus x, it gives us 3x. And 90 plus 9, it gives us 99. Then applying the concept of division property of equality, so we divide both sides of the equal sign by 3. 99 divided by 3, that gives us 33. So the value of number 3, the value of x in number 3 is 33. I hope the concepts on parallelism and perpendicularity are clear to you. Thank you for listening. This is Bunyasa Kappa, your math teacher. Have a nice day.